Now, you and I, we deal with base 10, decimal. So when you write a number, you go, as a single digit would be what? 0, 1, 2, 3, 4, 5, 6, 7, 8, and the last digit is 9 for a single digit, because we use base 10, decimal. Our computers don't speak that language. They speak machine or binary language. So in base 2, which is binary, it's either 0 or 1. That's what a single digit is. You can't have more than 0 or 1. It's always 1 less than the base. So if it's base 10, 0 to 9. There are some computers, especially the government defense, that try to make something bizarre, like so nobody can break the code. They might use base 8, and that's octal. Base 8, that means you go 0, 1, 2, 3, 4, 5, 6, or 7, a single digit. Another base that we talk about too is base 16, hexadecimal. Hexa. Base 16, that goes from 0 to where? To 15. Seven, 8, 9. You can only use a single digit. So how do you write a single digit when you get to 10? Well, A. We use A as 10, B as 11, C, D, E, and F. F is 15. So A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. So today we're going to learn how to go between bases, to change a number from base 10 to base 2, from base 10 to base 8, from 16 to 8, 16 to 10, back and forth. How do you change them? Remember, you and I understand that base. If somebody came to you and says, I got a number, you know, I went to my bank account today and it shows my balance on my bank account. It's 29A B3. That's my balance. What is that number as decimal number? I don't understand what that one is. It, do I have 29,000? Do I have 100,000? What do I have? So I need to be able to convert that number from hexadecimal to something I can understand. Base 10. So this is base 16. How do I change that to base 10? Or maybe I want to change it to binary, base 2. So that's really what I'm going to be doing today, converting numbers from one base to another. I don't have to do this example yet. I'll wait on this for a few minutes. We'll see where your balance is shortly. But how do we convert? Let's start from base 10 to base 2 first. Then we'll go 10 to 8, 10 to 16, then do the reverse. And I'll start first with whole numbers, I'll do decimal numbers. So I'm going to go from base 10. What do you want to do first? To binary? Base 2. Let's take a number like 294. That's base 10. Now I need to convert that to binary, base 2, because I'm going to feed that to the computer there. When you and I type in 294, your machine will have to take that number, the 294, and change it to ones and zeros. So let's see what that number. The way we do that, we take the 294 and we divide it by 2. So I need a calculator here. A number is too big? Well, I can do it actually in my head, but I'm lazy. 147. What's the remainder? 0. If you take 147 and you divide it by 2, is that a 73 and a remainder of 1? If you take the 73 and you divide it by 2, 36, remainder of what? 1. 36 divided by 2, 18, remainder of what? 0. 18 divided by 2, 9, remainder of 0. 9 divided by 2, 4, remainder of 1. 4 divided by 2, 2, remainder of 0. 2 divided by 2, 1, remainder of 0. And 1 divided by 2 is 0, remainder of 1. Once you hit a 0 here, you are done. And since you and I write from left to right, so I'm going to read these numbers upward. So it's going to be 1001, 1001, 00110. That's what 294 in base 2 will be. So we have to convert that to that number so the machine will know what we're talking about. Did we do it right? Can we test it? How do we go from base 2 to base 10? Well, just like when you write a number, I'll wait till you finish writing. When you write 294, remember in math, each one of these digits has a weight. This location is known as what? The ones, right? The one next to it is known as what? Tens, and this is what? Where do they come from with these names? Where's these names coming from? What is 10 to the power of 0?
1.
That's why it's called the ones. What's 10 to the power of 1?
10.
That's why this is the tens. And what's 10 to the power of 2? That's why this is known as the 100. The next one is 10 to the 3, which is what? 1,000. Well, this is the same thing. If we take that number, we know the weight of each one. Let me write that number down. 1 0 0 1 0 0 1 1 0. That's the number. I want to change it to base 10 to see if it's really equal to 294. Again, the weight of this location, the weight, it's 2 to the 0, which is what? What's 2 to the 0? 1. The weight of this location is what? 2 to the 1, which is 2. The weight of this one, 2 to the second, which is what? 4. The weight of this, 2 to the third, which is what? 8. The weight of this, 2 to the 4, 16. This one, 2 to the 5th, 32. 2 to the 6, 64. 2 to the 7, 128. And 2 to the 8, 256. Let's see what that number is. What is 0 times 1? 0 times 1 is 0. Plus, what's 1 times 2? 2. Plus, what's 1 times 4? 0 times 8? 0. 0 times 16? 0. 1 times 32? 32. 0 times 64? 0. 0 times 128? 0. And 1 times 256 is 256. And let's add them. 256 plus 32. Is that 288? 288 plus 4, 292 plus 2, 294. So I guess we did it right, because we came up with the correct answer. That's how we convert from decimal to base 2 or base 2 to decimal. Except if you have a decimal value. So let's say I have 0.24 base 10, and I want to change that to base 2. If it's decimal, instead of dividing by 2, you multiply by 2. That's what? 0.48, or 0, the whole digit 0 plus 0.48. Because that digit here is 0.48. I'm going to write that digit separate. 0.48 times 2, 0.96, right? .96 times 2. I chose a lousy number. It's going to be a long one. 1.92. So it's 1 plus 0.92. 0.92 times 2. 1.84. 1 plus 0.84.
We have to go to that right column and 0?
Yes, because that gives you the digits here now. You take the 0.84, multiply it by 2, 1.68. So 1 plus 0.68. So now we take the 0.68 and we multiply it by 2. 1.36, 1 plus 0.36. 0.36 times 2. 0.72, right? 0.72 times 2. 1.44, and it keeps going. And sometimes there's no end to that, so with a decimal value we read them down. So the answer in binary, here's the decimal point, 0, 0, 1, 1, 1, 1, 0, 1, and more. There's more digits to come. I just ran out of space. Unless they say to you, your machine is an 8-bit machine. If it's an 8-bit machine, what does that mean? You're only going to see the first 8 bits. If it's a 16-bit machine, you're going to see 16 digits there. So if it's an 8-bit machine, 1, 2, 3, 4, 5, 6, 7, 8. That's all you're going to see. That's it. So that's how we do the decimal value. If you were to convert again the reverse from decimal to base 10, instead of dividing, what do we do? Multiply. So I'll take another one. Oh, let me put a space there. Now let's go back to decimal again. When you had a decimal number, you wrote, let's say, 0.496. We call this location what? The 10th with a TH. And the one after it was what? 100th. And the one after is what? 1000th. Why? Why they call them that? Because the weight of this location is what? It is 10 to the negative 1, which is what? The 1/10th. That's why it's, or 110, which is a 10th. This is the 10 to the negative 2, which is what? 100th. And this is 10 to the negative 3, which is what? 1,000th. That's the weight of them. Well, with base 2 is the same thing. So when you look at that number, the weight of this one, you're in base 2. This is 2 to the negative 1, which is 1/2. This is 2 to the negative 2, 1/4. This is 2 to the negative 3, 1/8. And this is 2 to the negative 4, 1/16. So it's going to be 1 times 1/2. What's 1 times a half? 1/2. 0 times 1/4. 0. 1 times 1/8. How about 1/8? 1 times 1/16. So if you want to find the LCD for them and divide them later, that's 4/16 and 2/6, that's 7/16. 2/16, 4/16, and 1/16, right?
Half is 8.
Oh, 8. You're right. 8. 8 and 2 is what? 10, 1, 11. 11/16. That's a half, not a fourth. This is 8/16, 2/16, that's a 10/16, 11/16. .6875. So as a decimal number, that's 0.6875. So when you have a mixed number, you got to do them separately. You can't divide everything by 2. You do the whole numbers by dividing by 2. You do the decimal by multiplying by 2. Again, I'll do a quick example. Another one. I'll make it small enough. Not a huge one. Let's say I have 110.625. I'm going to do it as 2 separate problems. Here's my decimal point. On this side, I do the whole number. On this side, I'm going to do the decimal number. So I'll do one at a time. 110 divided by 2 is what? 55. And what's the remainder? 0. $55 divided by 2 is what? Is that 27? Remainder 1. 27 divided by 2. 13, remainder 1. 13 divided by 2. 6, remainder of 1. 6 divided by 2. 3, remainder of 0. 3 divided by 2. 1, remainder of 1. And 1 divided by 2. 0, remainder of 1. Once you hit the 0, you're done. Again, these numbers, you read them upward. 1, 1, 0, 1, 1, 1, 0. Now the decimal portion, you multiply by 2. 0.625 times 2. 1.25. 1 plus 0.25. 0.25 times 2. 0.5. 0.5 times 2. It's 1 plus 0. Once you hit a 0 here, you're done. And again, the decimal ones, you read them down. In this case, even if you did it upward by mistake, you end up with the same answer. 101, but you read them down. So that decimal number is equal to that in binary. I'm spending a lot of time on base 2 here, because once you understand that, it doesn't change for base 8 or 16. It's the same process. You'll see that. Exactly. I'll do a reverse one. 1011.111001. I don't know. This is base 2, and I want to change it to base 10. Again, the weight of this location is what? 2 to the 1. What's 2 to the 1? I mean, sorry, 2 to the 0, which is what? 1. The weight of this one, 2 to the 1, which is what? 2. The weight of this, 2 to the second. 4, 2 to the third, 8. So it's 2 to the 0, 2 to the 1, 2 to the second, 2 to the third. That's the weight of each one. This one, 2 to the negative 1. What's 2 to the negative 1? 1/2. This is 2 to the negative 2, which is what? 1/4. 2 to the negative 3. 1/8. 2 to the negative 4, which is what? 1/16. One times 8, 8. 0 times 4, 0. 1 times 2, 2. 1 times 1 is 1. 1 times 1/2, 1/2. 0 times 1/4, 0. 0 times 1/8, 0, plus 1/16. 11, what's 1/2? and 116. That's 916. 11 and 916. So it's 11 point. Let's see what 916 is. .5625. 11.5625. The same set of rules apply to base 10, base 8, base 16. I'll do a couple of quick examples, and we are done with the numbers. The good news about base 8 and base 16, because the base is big, it doesn't take that many steps. So if I have, for example, 513.24, the 4 is horrible. Let me try something else. At 24, how about 0.5? 0.25, base 10. And I want to change that to base 8. .513 divided by 8. Is it 64? Plus, what's the remainder? 1, right? 64 divided by 8. It's 8 plus what? 0. 8 divided by 8. 1 plus 0. 1 divided by 8. It's 0 plus 1. It looks binary. I don't like this example I chose there. Just pure luck. 1, 0, 0, 1. It looks like a binary number, but it's not really meant to be that way. I wish we had a remainder of 3, 2, whatever. 0.25 multiplied by 8. 2. And a remainder of what? 0. Once you get a 0, you're done. That's 0.2. I didn't do a good example here. Like, I don't like these numbers because it looks like binary, but it's not. If I made that maybe 616, that number will not be a 1, will be a 4. So you get to see it's not really binary. I just didn't think about it. Now, if I want to know if I did it right, again, from 8 to 10, the weight of this location, this is 8 to the power of 0, which is what? 1. This is 8 to the 1, 8. This is 8 to the second, 8 times 8, 64. This is 8 to the third. Is it 512? Yep, 512. And this one, 8 to what power? Negative 1, which is 1/8. So 1 times 512 is 512. 0 times 64 is 0. 0 times 8, 0. 1 times 1 is 1. 2 times 1/8 is 2/8, which is what? 1/4. 512 plus 1 is 513. Point, what's 1/4? Isn't that 25?
Is it always quicker, like, going back the other way?
Because you have fewer numbers. You know, once you know the weight of them, yes. Well, it depends how many numbers you got there. If you got a whole stack of ones and zeros, still going to be like 2 to the 1, 2 to the second, to the third, to the fourth. Get all these numbers first, then do it. Now the hexadecimal, $413. Base 10, I want to change it to base 16. 16 is bigger than 10, so you should have smaller number than that number. So well, let me put decimal value with it too. So I'll do both in one shot. 413 point. What are we going to do? 15? 125. That was the reason why I did 0.125. That's 1/8. 1/8 times 16. Boom, you're done with it quickly. I don't want to spend too much time. So 413, we'll do this side first. And the 0.125. Divided by, we go into base 16, by 16. It's 25 plus a remainder of 13. It is 13, yep. Next one, 25 divided by 16. It's 1 plus a remainder of what? Is it a 9? And finally, 1 divided by 16, which is 0 plus a remainder of 1. Again, I hit the 0, I stop. And I read them this way. 1, 9. Wait a minute, I can't write 13.
C.
That's a C. A is 10. B is 11. C is 12. D is 13. D. A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Now let's look at the decimal value. 0.125 times 16. That's a 2. Decimal value is 0. Once that's a 0, you stop. So 0.2. Now I didn't forget about that problem with your balance at Bank of America. Your balance was 2, 9, A, B, 3, base 16, right? And I want it in terms of something I can relate to. Because I have no idea what that means. Gibberish to me. No decimal value, good. The weight of this is 16 to the 0, which is the 1. 16 to the 1, 16. 16 squared, 256. 16 cubed, 16 to the power 3. 4096, is it?
Yep.
And 16 to the 4th.
Can I have this guy's bank account?
Yeah.
65536. So here's my balance. 2 times 65,536 plus 9 times 4096. A is what? 10? 10 times 256. B is what? 11 times the 16 plus 3 times 1. Hopefully we're going to have good money there. If I push all the right buttons, I have what? 170,675 bucks. So that is my balance.
That's your balance? That sounds pretty good.
Well, that's what it was. If I want to go from base 16 to base 2, looks like I got a problem. Base 16 to base 2, or base 8. I'll make it a smaller one.
Do you not just divide by 8?
No. Good idea, but because if you divide by 8, you're going to have a remainder of 7. Right? 5, 7, 6, 4, you're going to have some numbers. So the way we do that right now, we can change that to base 10 first. Then from 10 back to 2. So there's the 4 and there's the B. Base 16. The weight of this is 16 to the 0, which is the 1. This is 16 to the 1, which is what? 16. That'll be 4 times 16 plus B is 11, 11 times 1. 4 times 16 plus the 11, it's 75. So I took it from base 16 to base 10. Now I can go from 10 to 2. We know how to do that. From 10 to 2, you divide by 2. So 75 divided by 2. What's 75 divided by 2? 37, and remainder of what? 1. 37 divided by 2. 18 times 2 is 36. 18, remainder of 1. 18 divided by 2. 9, remainder of 0. 9 divided by 2. 4 remainder of 1. 4 divided by 2. 2 remainder of 0. 2 divided by 2. 1 remainder of 0. 1 divided by 2. 0 remainder of 1. And that'll be 1 0 0 1 0 1 1. That's a long way to calculate that, to convert that. Do I have an easier way of doing it? Well, let me take a look. Let me see if I can come up with an easier way to go between 16, 8, and 2. Much easier. Maybe I'll use graph paper for that here, just for a second, to line things up. So here's decimal. This is binary. This is octal, which means base 8. And this is hexadecimal. Okay. The 0. We'll begin with the 0. In binary, the 0 is 0. The 1 in decimal, in binary, there's a 1. There's 2, 3, 4, 5, 6, 7, 8, 9. There is no 10, 11, 12, 13, 14. The largest number in hexadecimal is what? 15. In binary, there's only 0 and 1. There's nothing else. So you can't write a 2 as a single digit. But in octal, you have 0, 1, 2, 3, 4, 5, 6, 7, all the way through 7, right? Octal's base 8. So you can have, so for binary, you can only go as high as 2. That's it. Stop right there. In octal, the biggest number is 7. Now, if I write that in binary, there's 3 digits for that. The weight of them, 2 to the 0, which is 1, 2 to the 1, which is 2, 2 to the second, which is 4, right? 2 to the 0, 2 to the 1, 2 to the second. It's called 1, 2, 4. So a 0 is 0, 0, 0. 0 in the 1 location, 0 in the 2, 0 in the 4. The 1 is 0, 0, 1. The 2 is 0, 1, 0. Why is it 0, 1, 0? Remember the weight. This has a weight of 1. This has a weight of 2. 0 times 1 is 0. 1 times 2 is 2. 0 times 4 is 0. You have the 2. A 3 is actually 2 plus 1. That's what a 3 is. So a 3 is 1, 1, 0. That's what a 3 is. The 4 is you want to put a 1 in that location and a 0 in these guys. 4 plus nothing is 4.
That's all binary.
Yep. In binary, yep. And I'm just thinking about octal, which is 0, 1, 2, 3, just when I represent that to binary. That's what I meant to say, like a 0, 1, all the way through 7. So 3 in octal, when you write that in binary, that's 0, 1, 1. 4 in octal, when you write that, that's 1, 0, 0. 5 is what? Isn't that 4 and 1? 5 is 1, 0, 1. So if you don't like the word octal here, we can eliminate that. But that's what this column represents, 0 through 7, the octal column. And this one represents the hexadecimal column. But I'm going to write that in binary. I'll put that just so you know we're dealing with just the first 7. 6 is 4 plus 2, right? And 7 is what? 4, 2, and 1. So when you actually in octal, you have the number 7, you want to change it to binary, replace it with that. Now hexadecimal, to write them in binary, you need 4 digits. The first one is 2 to the 0, which is 1. 2 to the 1, which is 2. 2 to the second, which is 4. 2 to the third, which is what? 8. 1, 2, 4, 8. So you're going to need 4 digits to write that. So the 0 in binary will be 0, 0, 0, 0. 1 will be what? 1, 0, 0, 0. The 2, 0, 0, 1, 0. The 3, that's 2 and 1. The 4, 0, 1, 0, 0. The 5 is what? 4 and 1. The 6 is 4 and 2. The 7, 4, 2 and 1. Now what about the 8? Remember, the hexadecimal can go as high as 15. So the 8 is going to be 8 plus nothing. The 9 is 8 and 1. The 10, 8 and 2. 11, 8 and 3. 12, the 8 and 4. 13, 8, 4 and 1. 14. Am I off track here? Looks like I'm missing one maybe.
You highlighted one line too far down.
I did?
Dash, yeah.
And the 15 is 1, 1, 1, 1. Yes, thank you. Yeah. So I can use that chart to go from hexadecimal to binary. And I wrote hexa on the top just to let you know we go 0 through 15 in hexa. With octal we go 0 through, but that's the equivalent binary. So now when you have something like the previous example we did here, you want to go from base 16 to base 2. You don't have to stop at 10. You go, wait, let me look at the 4. I'm going from 16 to base 2. I had 4b, right? In the previous one, base 16, and I want to go to base 2. Let's look at the 4 here in base 16. It's 0, 1, 0, 0. And the B is what? B is 11. So I can write the 11 here. I mean the A here, the B here, the C here, D, E, and F. So the B will be what? 1, 0, 1, 1. And if you have a leading 0 like this one, do you have to write it?
Yes.
Not really. Like in math, if you put a leading 0 like 0, 57, do you have to write the 0? The same thing. So if you look at this, you will see actually 1, 0, 0, 1, 0, 1, 1. See that answer is the same answer. So if you remember this chart, you can go back and forth much, much easier and quicker. Watch how quick I'm going to do some of these. I'm almost done. Oh, I'll do on this page while it's here. 7a b point c2 base 16, and I want to change that to base 8. Notice my space here. See that? Not much. Bless you. This is base 16. You write the 7 as what in base 16? 4 digits. 0, 1, 1, 1. Replace the 7 with 0, 1, 1, 1. Replace the A with what? 1, 0, 1, 0. Replace the B with what? 1, 0, 1, 1 as the point. The C, 1, 1, 0, 0. And the 2, which is what? 0, 0, 1, 0, right? Now again, any zeros in the front or at the end in any number are useless. So I can erase them, I can leave them in. But I need to change that to base 3. Now work backward, group them in groups of 3s instead of 4s now. And I can add more zeros, just like any number, you can add another 0 at the end. It's after the decimal point. So here's my decimal point. Let's look at this numbers. Now we're talking about base 3, octal. 0, 1, 1. Let's look at this chart. What's 0, 1, 1 here? That's a 3. Next one, 1, 0, 1. That's a 5.
That was 1, 1, 0.
1, 1, 0, yep. What did I say?
1, 0, 1.
It is
1, 0, 1 is 5. Yep, right there. This one, right? That's a 3. That's a 5. 1, 1, 0, that's the next one. 1, 1, 0, 6. 0, 1, 1, that's also what? 3.
But you said you don't need leading zeros?
You don't need them at any either end.
Okay.
But if you leave this, like you wouldn't know what that is, right? If you put 1, 1, you go, what's a 1, 1? So to make everything 3 digits, you can add leading zeros there. And lagging zeros after the decimal point. Now let's look at that number, 1, 1, 0. Isn't that a 6? 0, 0, 0, that's a 0. And 1, 0, 0, that's a 4. See how quick? If you just want it in binary, that was in binary. This is in base 8. So this one really here is in base 2. This is now in base 8. So you convert them like in 2 seconds by knowing that chart. And all I have to know is the weight of each location. This is the 1, the 2, the 4, the 8, the 1, 2, 4, and so forth. If you remember that, you can go back and forth much, much faster and easier. I'll stop here.